Today we are going to talk about weather patterns. You may need to pause this recording occasionally to fill in the blanks of your notes packet. Air pressure. Air pressure is the force of air molecules pushing down on an area. This is one of your vocab words that we have talked about in the past couple of weeks, so it should still be fresh in your mind. Air pressure and density decreases as you move higher in the atmosphere. What does decrease mean? Remember, decreases means to get smaller. So the higher you go in the atmosphere, air pressure gets smaller along with density. It gets less dense, less air pressure. Due to air pressure differences, air starts to move from areas of higher pressure toward areas of lower pressure. So why do you think that this takes place? Why do you think that air always moves from high pressure to lower pressure? Think about that for a minute. Things always move from high pressure to low pressure because weather is trying to maintain balance in the atmosphere. That is why air moves from high pressure to low pressure. Uneven heating of Earth's surfaces cause pressure differences. Where is the sun's rays concentrated at on Earth? The equator or the poles? If you said the equator, you are right. Is it hotter or colder at the equator? If you say hotter, you are correct. Is it colder or warmer at the poles? If you said colder, you are right. Because the sun's energy doesn't reach the poles as much as it does at the equator. Okay, as you can see, this is a picture of a barometer. A barometer is an instrument that measures air pressure. Now let's take a look at this barometer. You see it says rain, it says change, and it says fair. What does fair mean? Fair means sunny, clear skies. Rain, I think that pretty much speaks for itself. Okay, let's look at those numbers up at the top. That goes from 950 to 1050. As you notice, the higher numbers go with fair weather. So what this means is high pressure brings sunny, clear skies. And the lower pressures, as you can see, such as 950, 960, 970, 980, 990, those bring storms, hurricanes, tornadoes, rain. So low pressure, the type of weather that's associated with those are storms. Weather is a condition of Earth's atmosphere at a particular time and place. And wind is air that moves horizontally, which is parallel to the ground. Which direction is horizontal? Up and down or side to side? If you said side to side, you are correct. How wind forms. Sunlight strongly heats an area of the ground heats the air, the warm air rises, and an area of low pressure forms. If you can recall back when we took our notes on the Earth's atmosphere, and we were talking about radiation, we said that the Earth's sun heats what? The air or the ground? If you said the ground, you were right. The sun's energy heats the ground. Then the ground heats the air right directly above it. So, going on to the second bullet point. Sunlight heats an area of the ground less strongly. The cooler, denser air sinks slowly and an area of high pressure forms. Air moves as wind across the surface from higher to lower pressure. So again, air is moving constantly from higher pressures to lower pressures because think, if you have a higher concentration of something and a lower concentration of something, wouldn't that higher concentration try to move toward the lower to even it out? Or would lower move to higher to even it out? If you said higher to lower, you are correct. And remember, cool air always sinks, it's always slower, and it's always more dense. And warmer air is always faster, less dense, and it rises. Global winds. This is another vocab word that you have seen in the past few weeks. Global winds travel thousands of kilometers in steady patterns and can last for weeks. Coriolis effect. These are global winds that curve as Earth turns beneath them. In the northern hemisphere, winds curve to the right in the direction of the motion, whereas in the southern hemisphere, winds curve to the left in the direction of motion. Which hemisphere do we live in? If you said northern hemisphere, you are correct. Calm regions. So now we're going to be talking about wind belts, winds and wind belts. When it says calm regions, that doesn't mean necessarily that it has zero wind. It just means that it may have zero wind, or it may be that it has less powerful winds, very steady, very calm. So the first one we're going to talk about is doldrums. Doldrums are rising, warm, moist air that produces clouds and heavy rain. Heavy evaporation from the warm ocean fuels tropical storms. Low pressure at the equator. So, doldrums are located at the equator. So why do you think there is heavy evaporation that takes place here? Heavy evaporation takes place here is because it is very, very warm. So more evaporation is going to take place. Whereas, let's say if you were at the poles, would more or less evaporation take place? If you said less, you are correct, because is it warm or cold at the poles? It is cold, so less evaporation would take place. And it mentions about, with the doldrums, about tropical storms. If tropical storms get stronger and stronger and stronger, they can form what? They can form hurricanes. So if you were thinking hurricanes, you are correct. Horse latitudes. This is where warm air cools and sinks in these regions. And for the most part, clear and dry weather is located here. And you can find the horse latitudes at 30 degrees north and 30 degrees south. And again, this is high pressure. And here in Statesville, the latitude for Statesville, North Carolina is approximately 35 degrees north. So we're almost considered in these horse latitudes. Wind belts. Wind belts. The first wind that we're going to talk about is trade winds. They blow from the east. So they come directly from the east, they blow from the east and go west. They are strong and steady but die out before they reach the equator. So, let's go back a few hundred years, like to the 14, 15, maybe even 1600s. Did we have airplanes, trains, cars back then? No. For the most part, we only had ships to rely on to get from country to country to be able to import goods and export goods. So, sailors had to use these winds to guide their ships to get from one place to another to be able to trade goods. Hence, why it is called trade winds. Westerlies. Westerlies blow from the west. They go from the west and move to the east. They move toward the poles and bring storms across the U.S. Here in North Carolina, most of our weather does come from the west. Well, how do we get that weather from the west? Well, the westerlies blow that weather in. Then easterlies. Easterlies blow from the east, meaning they blow from the east, they start in the east direction and blow to the west direction. They move from the poles to the mid-latitudes. Stormy weather occurs when the easterly cold air meets the westerly warm air. Winds. You've got the jet stream that flows in the upper troposphere from west to east for thousands of kilometers. Troposphere, I believe we've seen that word several times before. Not only was that a vocab word a couple of weeks ago, but also we've had many activities dealing with this, such as your layers of the atmosphere drawing. So the troposphere, remember that is the layer closest to the Earth's surface that comes directly in contact with the Earth's surface where weather takes place. Sea breeze. Sea breezes occur during the day. This is where land heats up faster than the water. A land breeze takes place at night because land cools faster than water. So I'm going to provide you with a couple examples. Think about if you have ever been to the beach in late May, early June, or for the month of June. Okay? Now let's say you go to like a North Carolina or South Carolina beach. Usually during that month, temperatures on land are anywhere between mid 70s to upper 80s. Lower 80s. So we're talking 76 to about 83 degrees. Okay. Now let's say you go and jump in that water, that ocean water. Is that ocean water in June warm or cold or cool? If you said cool, then you're right. It is cool because the land heats up faster than the water. Now, let's think. Have you ever been to the beach in late August or for the month of September? If you have, usually the land temperatures are getting cooler. So the land temperatures would be anywhere between upper 60s, like 69, 68, to lower 70s, 71, 72, 73. Well, if you go and jump in that ocean water, is it warm or cool? If you said warm, you're right, because land cools faster than the water. That water's had several months to gain heat through the summer months, so that's why it is still warm. This is a picture of what a weather model looks like that meteorologists use. There are 4 different weather factors, that are being monitored on this model. And I want to draw your attention to 2 of them. This first top right one It has a capital L, and it's red, and a capital H, which is blue. What does that capital L stand for? If you said low pressure, you're right. What about the capital H? If you said high pressure, you're right. Then down here at the bottom right hand corner, this picture is a picture of the precipitation. This is the radar that's showing where the precipitation is located. And for this map, it's of the entire U.S. So for this day, it's showing where the precipitation is located in the U.S. So those are just a couple examples of what meteorologists use in their day-to-day field work. And also I have included in your notes a picture of the sea and land breeze diagrams. And this is just a diagram to reiterate, or means to repeat, what we just covered about sea and land breezes. Okay, with land, okay, for the sea breeze, land, we said, heats faster than water. So we've got this warm air, which we said rises. And as it rises, through the troposphere, it cools off and it travels over toward the ocean. It circulates. Well, as it cools off, well, cool air, it's more dense, so it's going to sink. And it's going to travel back. And it's going to heat back up. And as you can see, it's going to circulate. Okay. Then, for a land breeze, we said that land cools much faster than water. So cool air, we said, sinks or falls, and it travels out over the ocean, which the ocean, of course, is still warmer. So that warm ocean water is going to heat the air directly above it by warming it. And whenever that warm air, because it rises, it's less dense. Whenever that warm air rises, it's going to cool and again sink. And that's what generates the land breeze, that flow. Water in the air. Evaporation. This is where liquid changes into a gas, and it needs extra energy in order to do that. Condensation is a gas, and that gas is referred to as water vapor, which changes into a liquid. When moist air cools, this occurs. Precipitation is any liquid or solid water that falls to Earth's surface. Does that mean it's only rain? No. It can be rain, snow, sleet, hail, and those are just a few of the options. What depends on the type of precipitation you get is the temperature of the atmospheric layer that it is falling through. Here's a picture again of the water cycle. As you can see, evaporation takes place, which is where those water droplets become water vapor. The hotter a place is, the more evaporation that's going to take place. Well, as those water droplets turn into water vapor, the higher they go up in the atmosphere, the colder it gets. So that water vapor is going to cool and condense and turn into water droplets, which form a cloud. Well, if those clouds are holding all they can hold as far as water droplets are concerned, they can't take on any more water, they're at maximum capacity, then that's when precipitation takes place, whether that be rain, snow, hail, sleet. And after precipitation, it starts the cycle back over. Humidity. Humidity is another vocab word that we've covered in the past couple of weeks. It is the amount of water vapor in the air. Saturation. This is the rate of evaporation and condensation are equal. So what this is saying is once the atmosphere, which is the clouds, are holding as much water as they can possibly hold, and then it starts to rain, that means that the atmosphere is completely saturated. It can hold no more water vapor. Relative humidity compares the amount of water vapor in the air with the maximum amount of water vapor that can be present at that temperature. So this is comparing how much actual water vapor is in the air versus how much it could possibly hold. Dew point, this is the temperature at which air with a given amount of water vapor will reach saturation. Now think back to the summer months. Early in the morning, did you ever go outside? If so, was the grass wet? Yeah, the grass was wet because of the dew. And this is where the dew point comes in. This is where water vapor condensed on the grass. How clouds form. Clouds are made up of condensed water vapor, which by now I think we should know that. Well, as warm air rises in the atmosphere, it cools. It cools at its dew point. The water vapor condenses into tiny droplets or ice crystals and attaches itself to particles such as dust, smoke, and salt from the ocean. So in other words, you've got to have a particle of dust or smoke or salt in order for a cloud to form, because those water droplets have to have something to cling on in order to initially start building a cloud. It's got to have that. Well, how did that salt get there? Well, think about the ocean. It's got salt water. Evaporation takes place. So those water droplets are being evaporated up into the atmosphere. So those dust particles are, those salt particles are suspended in the atmosphere. So any other water particles that is evaporated, then they can cling on to those salt particles, forming another or a new cloud. The three main types of clouds include cirrus, which cirrus is Latin for curl of hair, and the description of cirrus clouds are they appear feathery or wispy, like a horse's tail or paintbrush strokes, wispy. Cumulus. Cumulus is Latin for heap or pile. These types of clouds can grow to be very tall, and sometimes they are nicknamed cotton balls or pillows. They look like that. Stratus is Latin for spread out, which the description for that is they have flat layers. These are the three main types of clouds. Does that mean these are the only types of clouds? No, but we're just covering the three basic types. Some key words or terms for you to know are nimbo or nimbus, meaning if you were to add these prefixes or suffixes to one of these three main cloud types, that means that they then produce precipitation. So let's take, for instance, cumulus. Cumulus clouds themselves, do they produce precipitation? No. However, if you have cumulus and you add on nimbus to that, so you've got cumulonimbus, do they then produce precipitation? Yes, they do. If you were to add the prefix alto to one of these three main types of clouds, what does that mean? It means that that stratus cloud or that cumulus cloud or that cirrus cloud is at medium altitude in the atmosphere. Remember, altitude is the height above sea level. Cirrus clouds. These form in cold air at high altitudes. They are wispy or feathery in appearance. Fair weather. These are to indicate fair weather, but they can also be a sign a storm is approaching. So cirrus clouds are usually found in fair weather. However, maybe later on that day or the next day, you might have a storm that is approaching. So that's a key indicator whether or not a storm is coming. Here are 4 pictures, and as you can see, they're different, but they're all types of cirrus clouds. And in your notes packet, I have included one of these 4 pictures. So what I would like for you to do is find that picture in your notes packet and label that picture as a cirrus cloud. So do that now. Cumulus clouds. These are puffy white clouds. They look like cotton balls. These appear in daytime and fair weather when warm air rises and the water vapor condenses. If they keep growing, they can produce showers. What does it mean by growing? Growing means that they are getting taller or wider, meaning they have more water vapor in them. And again, these 4 pictures are all pictures of cumulus clouds, but I chose one and put it in your notes packet. So what I would like for you to do is find the correct picture and label it a cumulonimbus cloud. If cumulus clouds keep growing, then cumulonimbus are formed, aka, which means also known as thunderheads. These are the tallest clouds, and heavy rainfall and severe weather are usually produced with these, such as thunderstorms and tornadoes. Again, I've included 3 pictures of cumulonimbus clouds. One of them is in your notes packet. Be sure to label the correct cloud as cumulonimbus. I want to draw your attention to this first picture of cumulonimbus clouds. As you can see, it has a flat base, which all of them do. They have flat bases and they're usually really dark, either black or dark gray because of the water, of course. Well, let's look at this first picture. Up at the top, you see how it levels off. That cloud just stops. Well, what this is showing is where this cloud has leveled off. This is actually the top of the troposphere, meaning where that cloud has leveled off, on the other side of that cloud is the next layer of the atmosphere, which is the, if you said stratosphere, you're right. So that is the top of the troposphere. Right after that, the stratosphere picks up. Stratus clouds. They form in layers when air cools over a large area without rising, or when the air is gently lifted. These are low, smooth, gray layers of clouds. They produce steady, light precipitation. So, let's think back to some of those days that we've had in the past that are just cloudy. The clouds are kind of low altitude, and you have steady rain all day long, but no big downpours. It's just steady, constant rain. Well, those types of clouds produce that. So those dark, gloomy days that rains all the time, whenever we have those types of clouds, That's what stratus clouds are. Again, here are 4 pictures of what stratus clouds look like. I have chosen one and placed it in your notes. You need to find that picture and label it stratus cloud. Precipitation. Doppler radar is the type of radar that meteorologists use to take a look at which areas different places are getting precipitation. So again, Doppler radar, it says it shows which areas are getting precipitation and how fast it's falling. So it's looking at the rain rates or the snow rates. Whatever type of precipitation that's taken place, it's looking at how fast it's falling. Now, the following are different types of precipitation. Rain and drizzle is one. This is where water droplets or ice crystals that melt as they fall. So as these water droplets are falling through the air, through the atmosphere, they are melting. Freezing rain is rain that freezes when it hits the ground or other surfaces. So, whenever you have freezing rain, it's raining like normal. However, it's so cold out, the surfaces are cold, that when it hits the surface or the ground, it automatically freezes. That's what freezing rain is. Sleet. This is rain that freezes into ice pellets while falling through cold air. So this is rain, but once it reaches a portion of the layer in the atmosphere that is really, really cold, it's freezing, then that's whenever those water droplets then become ice pellets and they fall to the ground. Snow. Snow is ice crystals that merge in clouds. Hail is ice pellets that move up and down constantly in clouds, growing larger as they gain layers of ice. So those ice pellets are constantly moving up and down and up and down and up and down in clouds. So it's gaining more water droplets. So it's getting bigger and bigger and bigger. That's why you sometimes have little old hail that might be dime size all the way up to golf ball size up to softball size hail. So it just depends on how long it has rotated in those clouds and gained more ice. Acid rain. This is more acidic than normal rain due to pollution. This type of rain damages buildings and sculptures. So here are some pictures to show you the different types of precipitation. The first picture that you see up in the top left hand corner is just normal rain drizzle. Then the second picture you see is freezing rain. As you can see, you've got a park bench, you've got a couple of cars, and it looks like you may have a little meter reader, a little meter that calculates the time that car's been there, and it is completely frozen over. It's a solid sheet of ice. So what that means is as that rain fell, normal rain, it froze to the surfaces of those objects because the objects or the surfaces were that cold. Then you see a road. On that road is sleet pellets, ice pellets. Down on the second row of pictures, you see a picture of a snowflake, what an actual snowflake looks like. And no two snowflakes look exactly alike. All snowflakes are different. They have different patterns. The middle picture on the bottom you see is a picture of, you can see in the very, very back, it is a picture of a vehicle driving through this road that has been plowed really, really high because this is lake effect snow. Lake effect snow is where you get a ton of snow, and it usually occurs up near the Great Lakes, which is in the northern part of the U.S. Then, in the bottom right hand corner, you see a man, or it could be a woman, shoveling the top of the roof. They're shoveling off the snow. Why do you think they would be shoveling off the snow? They would be shoveling off the snow because snow is so heavy once it starts to pile up. So they have to shovel it off, or if they didn't, it would cause the roof of their home to collapse. On this slide, you see several different things. You see different size hail. You see the hailstone up at the top left hand corner. A hailstone that is softball, baseball sized. Then down below it, you see what looks like to be quarter sized hail. Quarter sized hail. Then you can see what type of damage hail can do. That's a car's windshield that has been busted out due to the hailstones. It will also dent a car's body frame, depending on the size of the hailstone and how fast it falls. Then, down below that picture, you see a gravestone marker. That's what has taken place because of acid rain over time. The acid rain has eaten away at that limestone. That's also why you cannot see the person's name, the dates, the birth dates, the death dates, and any of that information is because the acid rain has eaten away at that limestone. And these are the resources for the images. Okay, that is it. So go back and review your notes packet. Make sure you have all your blanks filled in with the correct information. If not, you may want to replay this to make sure you got everything filled in correctly.